Hi everyone, in this tutorial we'll build this parametric expansion joint in Revit. This expansion joint will be controlled by a CSV lookup table, so when I change the size, the geometry will update automatically. I'll start with opening the Pipex template. You can download it on the Pipex website, the link is in the bio. First, I'll need to create a few reference planes for flanges. Then I'll go to manage project units, and here I want to make sure that this project uses millimeters for project units. So now I'll create a few more reference planes and add dimensions. And I'll need a dimension for the outside diameter of the expansion joint, of course. Here I'll create a new parameter, we'll call it D1. And for this dimension here, I will also create a new parameter. It will be a family, a shared parameter from our Pipex shared parameters file. So here I need to find the right category first. It is likely geometry category, length, and we'll use this parameter. I'll make it instance. Okay. So next thing we need to do is add a few more reference planes. I'll keep it static. I don't want this dimension to be or dynamic. So that's actually too much. I would like to keep it at 20 millimeters. So maybe we need to move the reference planes. 20, and I'll lock this dimension. Okay, great. In the next step, I'll go to family types, and as I mentioned, we'll use a CSV table. So I'll import the right CSV file and click OK. And then we need to find the Lookup tab parameter here and add the name of this CSV file as a formula. It shouldn't necessarily be a formula, but this is how I prefer to do it. Yes, and continue. Now I'll add a few formulas. There will be size lookup formulas. So I'll copy them from another Revit file and simply paste it here. But no worries, we'll upload this Revit family together with a CSV file, so you'll be able to find everything. There's an arrow. I will set this value to 0 because the table contains only a few certain values and we cannot randomly type in anything we want. All right, so yeah, I will continue. Yes, quite a few dimensions must be added. So next thing. All right, so it's the last formula that I add for now, and we can continue. Also here I want to keep it at 20 millimeters and lock this dimension. I'll add 2 more reference planes for the inner diameter of the expansion joint. And we'll select this dimension and DU. Okay, great. This reference plane here we'll need for the bellow. I want to simply lock it between the existing reference planes like this, and this is the thickness. Okay, so now we can start creating the geometry. I'll use the Revolve tool and we'll draw a rectangle first. I'll click the padlocks, draw another rectangular On the other side, also here, click the padlocks, and then I will pick the axis of rotation. Okay. I'll need 2 more reference planes for the next element we will create, like this, and we'll add dimensions, of course. And I want it to be simply equal to this thickness of the flange. The same on the other side. And here we want to create another revolve. I'll draw this line and click OK. Same we'll do on the other side, on the right side. So in the next step, I will create a new Revit family, and then later we will load this family into the previously created one. And here I will use the metric generic model template. Open. In this family, we'll create the bellow, the expansion joint. So let me start with adding a few reference planes. So for this dimension, we'll create a new parameter and call it D. This parameter will call the H thickness and make it instance as well. And then what we still need to do is add a few more reference planes like this, and then I'll change the scale because it's difficult to see the values. Alright, so I'll create a new parameter. We'll call it L1. This is going to be our thickness. So I'll need to use a different name, of course, so we'll call it a th underline 1. We'll call this a new parameter d1. Okay, and here, so it is our d. So now we can create a revolve. I'll use a line to draw a shape that we'll use creating the geometry. Another thing I want to do, I want to round the corners of the shape. Alright, so here's our revolve. Now we can load it into the project. So we'll need to align it with the central reference plane. Like this, great. Alright, so now we need to create new parameters for these dimensions of the bellow element. I'll start with L1. And then for the D parameter, call it D2. Make it instance. No, actually D2 we won't need for this. For the D, because for this parameter we can simply connect to this one and one DU. And the D parameter we've created, D2, this one will need for the D1. All right, so what's the problem here? So D1 is so feels like something about D1, about this parameter, so we'll try to fix it. Okay, now it worked. Great. So thickness I will keep at 1 millimeter, and this is thickness. Yes, this one will need. So I'll create a parameter, but this time call it thickness underline 2, ph underline 2. And now we can go to family types, and here we'll say that it will be 10 millimeters and the L1 will be 20, yes, 20 millimeters. No, he doesn't want to do something. So what I will do, I will select it and then click array, make sure that group and associate is checked, and then you can change the number of copies, but it's not that important at the moment. So 5 copies is perfectly fine. This and color correct it. Okay. Now I'll select our array and click on its dimension. Here you can create a new label, add parameter, and we'll call it BQ. Then I'll go to family types, and here you can find this parameter under other, and I'll add a formula for this parameter. But first I need to copy the name of one parameter, of the length parameter. All right, yes, it worked. So this is our expansion joint. In the next step, I'll go to the left view, and here I still want to create a few cylinders, a few elements around the flange, and then we'll create a few boxes. So I'll start with creating reference planes. Here I will add a new parameter. We'll call it L2 and make it instance. The same I'll do for the other direction. And now I'll create cylinders using the Revolve tool. I'll draw a few circles first. Here I'll create a new parameter. We'll call it rod underline D. Make it instance. Right, like this. And then we'll confirm. Oh, wait a second, something happened here. Yes, because it's not diameter. Fine, yes. Great. We can go to the front view and adjust the length of these cylinders, but first I need to add two more reference planes, one on the left side and another one on the right side, and of course we want to add dimensions. So I want this dimension to be static, I don't want it to be dynamic. I will simply say that it will be equal to 50. Yes, 50 should be fine, 50 millimeters, and then I will lock this dimension. And now we can say that we want our cylinders to start over here and end somewhere over here. It feels like they're too thick at the moment, so I will go to family types and quickly change it. 20 millimeters. No, I'm afraid it's way too much. So I'll maybe set it to 8. Yeah, I think it looks better. And we can go back to the left view and continue creating our boxes. We'll start with reference planes. all these dimensions, I'll use the same parameter, rod D. Select it from the list. And then I'll add one more dimension. This one here. We'll use a formula for this dimension. I will create a new parameter for them. Let's call it K instance. Okay. Now I can go to family types, find K, and I want it to be equal to rod D multiplied by 3. So let's see what we have. I still need to add a formula for the L2 parameters. So let's see how the situation changed, and now it looks definitely better. I would say that we can keep it like this. So now we can create our boxes. I'll use the extrusion tool and we'll draw a simple rectangular over here. Click the padlocks, of course. Like this, great. And then another one over here. Then we can go to front and adjust the location. So let's see. I want it to start over here and over here. And then I can mirror this element, these boxes, like this. And also on this side, I need to align the edges with the reference plane, like this. Great. So let's go to the 3D view, and oh, here's the result. So, and the last thing we still need to do is to add pipe connectors. Work plane, pickup plane, and then I'll select this plane. Here's our pipe connector, and another thing we need to do, we need to place it correctly in the view. So I'll move this dimension first, like this. Great. Then I'll set the value to 0, and here's our pipe connector. And we need one more pipe connector, so I'll go in again to create pipe connector, work plane. So I need to pick this reference plane. Here it is. Also here I'll set the value to 0 and change the diameter of this connector. Oh, that's a small typo. Let me check it. So I want it to be 100 millimeters. Right. So this is it. This is how you can create a parametric expansion joint in Revit. I hope you liked this video and see you in the next one.